Hi guys, in this video we're going to take a look at reducing bias in samples, simple random sampling, examples, and then we'll finish with a summary.
So how do we reduce bias when taking samples? Suppose we wish to pick a suitable sample from which we can infer an accurate description of the whole population. Let's say we want to choose a sample of students at a school to measure the progress of the students after 1 year. If we pick the first few members of the population, it is unlikely that the sample will be representative of the whole population. If we were to order the students, and we have here our first few members of the population, and we choose a sample from only the first few members, then this would not be representative. To obtain a non-biased result, we could instead pick the members of the population at random in no particular order. Before, we had to pick some kind of order, and this order could lead to bias. However, let's say instead we choose, say, this person, and this person, i.e. we take a sample chosen by picking students randomly from the population, then this leads to an unbiased sample in general. This process is known as random sampling. So what is simple random sampling? We know that sampling is when we obtain information from a subset of a population. Let's say we have the population of teapots from a factory. We can consider a sample of the whole population, and this is just a subset of the entire population. We can then estimate the number of teapots that are faulty in the population by using the subset or sample. There are different sampling techniques for selecting the members for our sample. We could take our entire population, and then how we pick our members for our sample, say this member, this member, this member, this member, and this member, depends on which technique we use to pick the sample. So whether we actually get these members or not depends on the technique. The question remains, how should we select the sample from the population? When carrying out a simple random sample, every individual of a population has an equal chance of being selected. A simple random sample is one where the individuals for the sample are chosen randomly from the population. Let's say we have in particular these members forming our sample, but a simple random sample is where each of these members of the population are equally likely of being selected. Every sample of the required size has the same probability of being selected. If we have this as our sample A, and we have this as our sample B, in simple random sampling, picking sample A has the same probability as sample B. The person conducting the survey cannot pick the individual members to make up the sample, so there is no bias. Let's say the surveyor, the person conducting the survey, does not actually pick the sample. It is random, and therefore there is no bias in the sample. The sample should therefore be representative of the whole population. If we consider our sample taken from the whole population via random sampling, then our proportion of faulty teapots in the sample should correspond precisely to the proportion of faulty teapots in the whole population. In particular, let's say there is 100 out of 500 faulty in the sample. We consider the 100 divided by the 500, and this gives us 1/5. And hopefully, we would find in the whole population that 400 out of 2000 were faulty. This is because our 400 over 2000 is going to be the same proportion 1/5. And the reason for these hoped equivalences is because in this case the sample should be representative. To carry out a simple random sample, we need a sampling frame, where each member of the population is allocated a unique number. Let's consider a sampling frame for the population. Each member of the population is allocated a unique number, 1 up to 8 in this case. And then we take our sample, say 2, 4, and 7, and we need to label each teapot so you can choose at random. Instead of picking teapots randomly, we now can just pick numbers randomly. We can generate a selection of random numbers using a calculator or by pulling numbers out of a hat. We can use the random number generator on a calculator, or we can pick the numbers from a hat. This process is called lottery sampling. However, this process can take a long time for large populations or sample sizes. On the calculator, the random number generator has to be used many times. Or with the hat, picking many numbers from a hat is a long process. There are advantages and disadvantages of simple random sampling. Let's start with the advantages. The sample is going to be free of bias. The method is easy and cheap. Each member has an equal chance of selection. Now, the disadvantages. The method is not suitable for large population or sample sizes. And also we need to have an initial sampling frame. Let's take a look at some examples. Our first example tells us that the 100 members of a debating society are listed alphabetically in the membership book. We're asked to explain how we could obtain a random sample of 12 members for a survey. The first step is to understand the need for a sampling frame, with the sampling units individually numbered. We need to allocate a number from 1 to 100 to each member of the debating society. Our second step is to recognise that random numbers must be generated to obtain a random sample. We can use a calculator, for example, to generate 12 random numbers from 1 to 100 and select the people corresponding to the numbers chosen. Our second example tells us that the mayor of a town wishes to take a sample of 10 residents from a specific district of the town. She has a list of all the residents numbered from 1 to 567. The mayor uses a random number generator on a calculator with numbers ranging from 001 to 999. She generates 10 numbers. Here we have the following 10 numbers. We're asked to suggest which could be the first 5 residents in the mayor's sample. Our first step is to recognise that the first 2 numbers cannot be used as they do not lie in the range 1 to 567. We have that 721 is strictly greater than 567, and 705 is also strictly greater than 567. Therefore, we cannot use these values because they lie outside our sample size. Our second step is to write down the first 4 values that the mayor can use. The next 4 numbers are 119, 374, 558, and 253. Each of these numbers lie between 1 and 567. So the mayor can use these first 4 values. Our third step is to recognise that the next 2 numbers cannot be used as they do not lie in the range 1 to 567. Our next 2 numbers are 830 and 947. 830 is strictly greater than 567, and similarly 947 is also strictly greater than 567. Therefore, the mayor cannot use these values. Our fourth step is to write down the 5th value that the mayor can use to form her sample. The next value is 428, and this lies between 1 and 567. So the mayor can use this as the 5th value. Our last step is to conclude which are the 5 first residents that could be in the mayor's sample. We could have the residents which are labelled as the first 5 suitable numbers, namely 119, 374, 558, 253, and 428. In summary, a simple random sample is one where individuals for the sample are chosen randomly from the population. In a simple random sample, every sample of the required
Hi guys, in this video we're going to take a look at an exam style question.
A company wishes to know what proportion of their employees have children. To do this, they would like to take a random sample of 20 employees from a workforce of 200. Part A asks us to define the terms census and sample, and this is for 2 marks. This is just a definition, so a census is a process in which one measures or observes every member of a population. Note the emphasis on every. A sample is a selection of observations or measurements taken from a subset of the population. This is for 2 marks, and we get 1 mark each for each of our definitions. Part B asks to describe how they could draw this random sample, and this is for 3 marks. So firstly, they would have to number each of their workers from 1 to 200. Then they would generate random numbers between 001 and 999, discarding any number greater than 200. They would then repeat this process until 20 numbers that are less than 200 have been generated, and select the workers whose assigned number matches the randomly generated ones. This was worth 3 marks. We get a mark for our sampling frame, i.e. numbering from 1 to 200. We get a mark for random number generation, and then a mark for how we use the numbers. When the sample is taken, it is found that 15 people in the sample have children. We are asked to estimate the proportion of people who have children in the workforce. So in the sample, we have that 15 out of 20 have children. This is equal to 3/4 of them. Therefore, the estimated proportion is 3/4. This was worth 1 mark, and we get our mark for our answer. We are asked to give one advantage of using the sample compared to a census in this context. This is for 1 mark. A sample is quicker to carry out as it involves polling a smaller number of people. This was worth 1 mark, and we get our mark for our advantage, i.e. a smaller number of people involved.